Hello everyone. Today we are going to show you how to measure the current in a circuit. For that, you have to remember that whether the motor, the buzzer or light, whatever it will be, it should be connected in series. Only then we can measure the current in a circuit. You have to remember that whenever we measure current, you have to put the ammeter in series connection. Here we are using a digital multimeter. In the same way, we will use this digital multimeter in series connection. And how you see we are measuring the current in this circuit. First of all, see how we connect the various equipments or various components of the circuit. How that I am going to tell you. First of all, what you have done, you see here that this is, you can see here that the red one is the positive terminal of the cell, this red one, and this black one is the negative terminal of the cell. First of all, what you have done is, you see here, this is the cell. First we connected the negative terminal of this cell, right, this one, and you see here we have connected this buzzer with the negative terminal of the buzzer. It is here from negative to negative, nothing else, right? After that, this buzzer is here. This is the buzzer. Now you see, this is the positive terminal of the cell, this one, right? I already told you, you have to connect the digital multimeter in series connection to measure the current. Here you can see that in digital multimeter there are 4 divisions. Here you can see, here in this case you can measure, this is in the off position of the digital multimeter, this is off position, right? And you can see here, this is the AC voltage. You can measure from 200 volt to 750 volt, and this is the measure for voltage, AC voltage. If you want to measure the DC voltage, you can check, you can check this DC voltage from 200 millivolt to 1000 volt. This is the range of this voltage, right? If you want to measure the resistance, then you can see here, you can measure the resistance 200 ohm to 2000 ohm, 2000 k ohm, 200, 2000, 20k, 200k and 2000k. You can measure the resistance, right? Here you see that if you want to measure the current, here you see there are 2 probes. One is for 10 ampere, this is for 10 ampere probe, and this is for this one, right? What you are getting, you see, this is DC current you have to measure. You can measure with this digital multimeter. You see here it is 2000 microampere, it is 20 milliampere, and it is 200 milliampere. That you can measure the current from here. And here you can see that this is the symbol of continuity, right? Here is the sound here and diode. You can check this from here whether it is continuous or not, and also we can find the direction of the diode, right? And this is the square wave, and this is the HFE, means you can find the beta value of any NPN or PNP transistors. Those I will show you in another video. First of all, today I am going to show you how to measure the current. You see, this is the current. So put this in the 220 milliampere current, right? First, actually we can measure the maximum current. After that, slowly we go to the lower section, right? Maximum is here, in this is 200 millivolt, right? Here we are putting this knob, and this, you know that this is the positive probe, the red one is the positive probe and the black one is the negative probe, right? Now see how to measure that I am showing you. First of all, you have to connect this digital multimeter in series connection with the circuit, within the circuit, right? Let's see how we can measure it, right? First of all, connect this probe with this one, right? We are connecting this one, and if we want to measure, then we have to connect this with this one, right? With the positive terminal of this buzzer, and we can find the value of current in this section. You see here, we are touching it, and let's see what happens. You see, it is showing that 10.4, it is 10.4 milliampere, right? The current you can see here in this case is 10.7 milliampere, 10.7 milliampere, right? You can see here that it is 10.7. You can see very clearly that it is 10.7 milliampere. We are getting the value of 10.7 milliampere. You just see this one and check it. 10.5, right? That means it is 10.5 milliampere, right? Or thus we can see that we can measure the current in series connection with different components in a circuit. Now you see, to measure the actual current, we can pure value, we take this knob to this 20 milliampere current. You see, this is 20 milliampere. Now if we check this one, what is the current? You see, we have connected this digital multimeter in series connection, right? You see here, now we are touching this one and rating what is the value. It is 10.46 milliampere. Whenever we put this either in this way, in this knob, or the knob is put in this position or in this position, and getting the same value. That is how to measure the current. Now if we put a resistance in between them, we will check that there will be various variable current there also. You see here, we are putting a resistance in between them, right? And let's see what happens. Here you see, we have put a resistance, variable resistance, and let's see what happens in this case, right? Now see, we are checking the current in this position. See, it is 0.16 milliampere, right? That is, the current had decreased due to resistance, right? Here you can see, and let's check. Remember that we have connected is in series. Since we have increased the resistance, you see, it is passing only 0.16 milliampere, because we have used a resistance here, 0.16 milliampere, right? If we change the resistance, let's see what happens. You see, we are changing the resistance here. Now see what happens to this reading of this current. 0.16 milliampere. We are getting 0.16 milliampere, right? That means we have decreased the current here, right? Now we are removing this variable resistance, and we will check for another component in this circuit. Let us take an LED, different LED. Let us take this LED, right? Here we are removing this buzzer, and we are connected this with a LED, red LED. This is the red LED. Let's check whether how much current it is passing through this LED, right? Now see, we are using this LED and we'll see how much current it is passing through this circuit. Like you see, you remember that we have connected all these digital multimeter in series. Let's see how much current is passing through it. You see, you can see the reading here. Yes, we are touching it, and the LED will glow, and you can see the reading in this digital multimeter. You see, this is, so it is fluctuating, but it is, we are getting a value that is nearly, we are getting a fluctuating current here. 58 like this, right? 58 milliampere, but we are getting a fluctuating current in this case of LED, right? Now we use a motor also, and so how much current we are getting in this connection. Remember that you have to put this digital multimeter in series connection, only then you can measure the current, otherwise you can't, right? Now let us check for another LED, right? Let us, if we change the LED, let us see how we can check it. If we put in the resistance, variable resistance here, you see how the current is changing, right? You are putting a variable resistance in this case, right? You are putting a variable resistance and see that there is a change in the current, right? Let's see. You can see the reading here in the digital multimeter. Let's see. You see the current decreases, that is, we are getting nearly 0.01 milliampere, right? You put it in here also, that is in 20 milliampere now position. Let us see 0.13 milliampere current we are getting in this case. If we change the resistance, let's see what happens. We are changing the variable resistance. We change the resistance, and let's see, if we change the resistance, there will be change in the current. You see, 0.13 milliampere, right? Let us change more, and let's see what happens. Now see, we have changed the very resistance again, and you can see here that it is 0.1212. That is, whenever we change the resistance, that there is a change in the current, you can see here, right? And let's see once again. Yes, whenever we change the resistance, there is change in the current also we are getting, right? Now if we change this component to another, that is, we are using a motor here, right? You can see that this is a motor, and we'll check the current in that case also, right? Let us see. We are changing this LED, right? And if we want to measure another LED, here you can see that we have taken another LED, red LED, and let's see what happens. We are using this one, and let us check what happens to this one. Now we use this one, we change the resistance here. We are removing this resistance, variable resistance, and direct it and connect it directly, and let's see in this case what is the current in through this LED. We will check it, right? You see here, we are See, we have connected it, and let's see how much current is passing through it. You see, it is nearly you can see that it is, though it is variable current, it is nearly 59 milliampere. That is, current has increased because we have removed the resistance, right? Now you can see, if we put a motor, we will see how much current it passes through it. Let's see. See, that is, though the current is fluctuating, it is nearly 180, nearly 100 milliampere, nearly, right? Though it is fluctuating, the current is fluctuating, or the ampere is fluctuating, right? In this way, you can measure all the components in series connection, right? Now, if we put a resistance here, what we'll see that what is the change in the current. You are putting a resistance, that is, we are putting a variable resistance here. You see here, we are putting a variable resistance here, and let's check how much current passes through this connection, right? But you have to remember that we have connected this component in series again, right? Let's see how much current we are getting now. We put a resistance here. No, resistance is high, that's why the motor is not rotating, because we have used a resistance, high resistance. You see this one, right? And very less current is passing through it, that's why it is not working. The fan is not working because we have used a resistance, high resistance, that's why it is not working. High resistance means low current, that's why it is not rotating. Let us check with a low resistance, right? We are putting a low resistance, and we'll check how much current passes through it. Here you see, we are using this resistance. We'll see how much current passes through this fan. Here you see, we are using this resistance. Now let's check how much current passes through this. You see, we have used the resistance here, and then check how much current it is we are getting.